In this lesson, we will determine equivalence for an ion and complete calculation relating equivalence to moles, volumes, or mass. The first question you may be asking yourself is, why do we even use equivalence? When a patient is receiving saline or a dextrose solution, it's important that the solution being given is similar to the normal bodily fluids to avoid any other problems. So we want to make sure that our ion concentrations in our solutions are similar to that in the blood. Without that, we can sometimes run into some issues with hypo or hypernatremia, which is a result of high or low sodium levels, or hypo or hyperkalemia, which is the result of potassium levels that are too high or too low. Because of the importance of the sodium-potassium ion exchange pump in our body, it's important that these are held at a correct concentration. Equivalents are easy to get from the ion charges, and when we find the equivalence, it has units of equivalence per mole. So this is a compound unit that can be used in calculations. For sodium, which has a +1 charge, we say that it has 1 equivalent per mole. Magnesium has a 2+ charge, so it has 2 equivalents per mole. Chloride has a -1 charge, so it has 1 equivalent per mole. And sulfur has a 2- charge, so it has 2 equivalents per mole. Notice that we do not put a negative sign in front of the values for chloride and sulfide, even though they are anions. The value for equivalents per mole is always a positive number. Note that we can also use metric prefixes within a unit, so 1 milliequivalent is equal to 10 to the -3rd equivalents. Let's look at an example of normal saline. It has a concentration of 0.9% mass volume of NaCl in water, which means we have 0.9 grams in 100 mils of solution. 1 liter of a normal saline solution contains 154 milliequivalents of sodium plus and 154 milliequivalents of chloride. What is the concentration in equivalents per liter for a solution containing 19.5 grams of calcium 2+ ion in 125 milliliters of water? We're looking for units of equivalents per liter. We see that we have milliliters, which can be converted to liters, so we need to find the value for equivalents. Calcium has the relationship of 2 equivalents per mole for the calcium 2+ ion. This is a relationship we can use to help us identify the number of equivalents in a specific sample. We're going to start with our 19.5 grams of calcium, and we need to convert this to moles because our equivalent value is 2 equivalents per mole. So we have 40.08 grams per mole from the molar mass. Grams will cancel. Next, I use my 2 equivalents per mole, which is true for calcium or any other ion with a +2 or -2 charge. Moles will cancel, and I find out that in 19.5 grams I have 0.973 equivalents. I can now use this along with my volume to find the equivalents per liter. So we have 0.973 equivalents over 0.125 liters, and we get a concentration of 7.78 equivalents per liter.